In this section, we're going to talk about how if two triangles have two angles that are congruent and a side not in between those two angles is congruent to another triangle, or they correspond to AAS in another triangle, these two triangles are congruent. Now, exactly what is this AAS? Well, if you have this angle, you have one triangle and a second triangle. If those two angles are congruent and these two angles are congruent, this would be the side, these would be the sides in between the angle. And if they were equal, you would have ASA is congruent to ASA. That is, the two triangles would be the same by ASA congruent to ASA. But this is not the case in this situation. We have two other sides other than the one in between these two angles. We can have those two equal or congruent, or we can have these two congruent. If that were the case, then triangle 1 and triangle 2 would be congruent. You can take this triangle, although I must admit it doesn't look like it, sorry, and lay it on top of this one, and they would match up perfectly. Say AAS is congruent to AAS. If two triangles live up to that, these two triangles would be congruent. Now, suppose you have a triangle like this. Let us call this triangle KMP, and we want to partition it as such. We go like this to point O, and we go like that to point R. And a few things are known about this. For example, so this is the givens. MR is perpendicular to KP. Likewise, KO and RM, they are also perpendicular. That is, they meet at right angles. And what we'd like to show, I guess we need one other thing. Angle RKM is congruent to OKM. Angle OKM. RKM, of course that's wrong. I want angle M in the middle. OMK. So this is given. And we want to prove that these lower two triangles, triangle 1, RKM, triangle RKM, and this other triangle to the right, namely this one, KOM, they're congruent. Okay. So, write this up. You have the given. You have the reasons. So like always, number 1 will be everything that's given. We'll call them the givens. And the reason is they're given. Okay, you can't argue with the information given unless it's contradictory. Unless things are contradictory. In other words, I say that KO and KM, they're perpendicular, which means they're right angles. And then the next given is this angle right here is 78 degrees. That would be a problem. Okay, number 2, I am going to say that angle KOM, this angle right here, and angle RKM, and angle, KRM are right angles. And the reason is perpendicular lines, they meet at right angles. So those angles are the same. And I'm going to say that KM, statement 3, line segment KM is congruent to line segment KM. And this is identity. Now, angle RKM, this angle right here, and angle OMK are given to be equal. Now, let us separate these two triangles. Let me put it where the given was. Okay, so what we have is RKM. And we have KOM. That's KM, and here's O. KOM. So they both have KM. That goes without saying. And big angle K, that is RKM, which is this angle right here, is equal to angle OKM, this angle right here. So we have that. And though my pictures may not look at it, KRM is the right angle. KOM is the right angle. Okay. Now let's see. Statement 3 said that those two are equal. The givens said that they are equal, congruent, and statement 2 said that those are right angles. Well, I have two angles and not the side in between. Yet another side. I have two angles, and the one opposite the right angle, those are the congruent ones. So now so now I can say that triangle RKM is congruent to triangle KOM. And the reason is AAS is congruent to AAS. Okay. And that completes the proof. I do want to go back and say something that I caught that I didn't say very clearly at all before. In fact, I didn't say it at all. If you have two triangles, of course, one of them can be rotated. If this angle is the same as that angle, and this angle is the same as that angle, and not in between, but this side and this side are equal. You cannot say that these two triangles are congruent by AAS. This is not true. This is not true. But you may say, well, they both have two corresponding angles, or two congruent angles, and a side other than the one in between the angles are equal or congruent. What the deal is there's two ways of thinking it. The side next to the one with one slash must be the one that's congruent in the other triangle next to the one slash. Or and that's not true in this case. Or how I would rather see it, because it's easier, is opposite the angle with two slashes and opposite the angle with two slashes, those should be the corresponding ones. But they're not. In the second triangle, the one opposite the one slash are the same. Okay, so not only do you have to have two angles, any two angles, and a third side not in between the two angles, but that third side has to be in their same location. That is, it must be opposite the one with two slashes. These are equal now. These two triangles are congruent, I mean to say. And I can get rid of the not congruent symbol. They are congruent. So it's just not enough to have two angles corresponding in one triangle and another, and then a third side. And then a side. If that side is in between the two angles, ASA by ASA, ASA, these two triangles are congruent. If the third side is not in between the two angles that are congruent, well, they have to be in the same location in the two triangles, opposite the 30-degree angle, opposite the angle opposite the angles that you called number 1, adjacent to the angles that you called number 1, something like that. Okay, suppose you have a circle. Centered right here. And you go like this and like that and like this and like that. By no means am I trying to say that the line I'm erasing here and here go to the end of the circle. Let's make that clear that it doesn't. Circle O. And what are you given? Well, you're given circle O. Given circle O. And you're also given that SOTWV, let's label it this way. You're given that angle SOV happens to be congruent to angle TOW, angle TOW. And angle WOS is in turn congruent to angle VTO. And something needs to be wrong here. This is WSO. And you want to prove the following, that SO and TO are the same length. SO, TO, they're congruent. Okay. So we have statements, we have reasons. The first one is everything that's given. The justification was given. Okay. Now, angle SOV which is this angle right here, is congruent to TOW, which is this angle right here. Now, basically, if I call the small angle there 1, and the angle in the middle 2, and this angle 3, we know that 1 plus 2, which is SOV, is congruent to angle 2 plus 3, which is TOW. And if you subtract angle 2, you'll have equality. That is, you'll have angle 1 plus angles, you'd have angle 1 and angle 3 equal. Okay, so statement number 2. Angle 1 plus angle 2 is equal to angle SOV. Sum of the parts is the whole. Also, angle 3 plus angle 2 is congruent to TOV. Angle TOV. The reason is the sum of the parts equal the whole. Spew. Sum of the parts equal the whole. Okay. Number 3. Basically, okay, so let's formally say it. Angle 1 plus angle 2 is equal to angle 3 plus angle 2. Why? Because the two quantities I just wrote down equal a common value. SOV and TOV, they were said to be equal. Number 3. If two quantities equal a third quantity, then the two quantities are in fact equal to themselves. And due to board space, I'm going to put it up here. If two quantities equal a third quantity, then they're equal to one another. If two quantities equals a third quantity, then these two quantities themselves are equal to one another. Now number 4, subtraction postulate. Angle 1 is equal to angle 3. Subtraction postulate. If you subtract equals from equals, their results are equal. Okay, so now I have angle 1 and angles 3 equal. Actually, what I'm trying to show is that this triangle and this triangle are equal. So I have one angle equal, and we were told this over here, that angle WSO, this angle right here, and VTO, this angle down here, they're equal. So right now I have two triangles, the red one and the green one, and they both have two equal angles. Okay. Now, I want to pretty much conclude that WO and VO are equal, congruent. And why is that obviously true? Why is WO and VO equal in length, congruent? Because they're both, each of them is the radius of the circle. Any line, any line segment that goes from the center of the circle to an endpoint of the circle is a radius. Any point that goes from the center of a circle to a point on the circle is a radii. Okay, so WO and VO are radii to circle O. And the reason is any line segment that goes from the center of a circle to a point on the circle is their radius. Now, statement 5 or statement 6, I hope you realize what that's going to be. Statement 6 is going to be that WO and VO are equal or congruent. WO is congruent to VO. And the reason is, not R, but all radii of a circle, all radii of circle O are congruent. All radii of circle O are congruent. Okay, number 7. Triangle SOW is congruent to triangle TOV. And why is that? Well, they do have two angles that are congruent, and they have a third side, WO and VO. Now, WO is opposite the angle with one slash. VO is opposite the same type of angle. And it's not in between the two corresponding angles. It's not in between, it's not that side and that side. If it were, I would say by ASA they're congruent. But in this case, I'm going to say by AAS. Now, we can conclude what they asked us to prove, that SO and TO are in fact congruent. Okay, SO and TO are the sides in between one slash and angle 1. One slash and angle 3. And remember, angle 1 and 3 were equal. Okay, so we can say that the reason is corresponding parts of congruent triangles are congruent. Okay, there's that proof. If two triangles have two angles that correspond, that is, they're congruent, and the third side, and the side not in between the two angles that are also congruent, and they're in the same location, the opposite corresponding congruent angles, then by AAS, these two triangles are in fact congruent. Okay, let us try one more. Suppose in this problem we have a rhombus. Okay, call a rhombus ABCD. And you have this line from B to E and you have another line from D to F. So what is given? You are given rhombus A, B, C, D. And you're also given that BE is perpendicular to DA. Likewise, DF is perpendicular to AB. And you want to conclude, you want to prove that those two lines other than the rhombus, that is BE and DF, those line segments happen to be congruent. Okay. Statement reasons. So basically, since this is the section to show that AAS is congruent to AAS, you should foresee the future. You want to get two triangles and show that they're congruent. And then I guess by corresponding parts, you'll get what you wanted to conclude. That will usually be correct. I mean, you can have a problem in this section that comes from an earlier section, and you get burnt. But this problem is an AAS, congruent to AAS problem. So number one is all the givens. The reason is it's given. Statement number two, I want to say, so now, what BE? BE is this side here. Well, it's part of that triangle. Okay, it is part of that triangle. Triangle A, B, E. And DF is this side, which is part of triangle DAE. Sorry, DFA. DAF. Okay. Call this angle 1. Call this angle 2. Angle 1 and angle 2 are right angles. The reason is perpendicular lines meet at right angles. Okay, now statement 3, I can actually say that these two angles are equal. Why? All right angles are equal. All right angles are equal. Okay, so we have angle 1, which is this angle here, and angle 2, which is that angle there. They're equal. They're equal. And one little thing I want to fix, angle D is up there. Okay. And in case it's going to help out, not only is that angle 1, but it is a right angle. Now, we know that AB and AD are equal because they are the sides of a rhombus. And we've already said ABCD is a rhombus. So AD is congruent to AB. Property of the sides of a rhombus. Okay. Okay. So in this diagram up here, angle 2 is a right angle, and angle 1 is a right angle. Well, of course, that's the right angle too, and there's another right angle. Okay. Oh, because it's not the case. All right. So now, somehow, okay, maybe I see it right now. They both have angle A. They both have angle A. That was a missing part for me. Angle A is congruent to angle A, and this is identity. But okay, angle A equals angle A. Okay, so now clearly in these two triangles, triangle 1 and triangle 2, we have one angle with one slash and a right angle. One angle with one slash and a right angle. Well, the side in the middle of those two angles, we're not told that they're equal or congruent. But you know what? The side opposite the right angle, we know they're equal. Okay, so number 6, triangle number 1 is congruent to triangle number 2. I numbered the triangle. If your teacher is going to say, well, you can't do that, well, then please, by all means, call it triangle 1, call it triangle ABE. And triangle 2, call it AFD. Those are congruent. And the reason is AAS congruent to AAS. Now, the conclusion. And you need to be careful. And of course, in a textbook or an exam, unless somebody made a mistake, they really are going to be corresponding parts. But maybe you're going to go and become a geometrist, and you have to make sure. Well, BE, this side right here, is opposite the angle with one slash. DF, which is right here, it too is the angle opposite the one with one slash. Therefore, they're corresponding. Corresponding parts of congruent triangles are in fact congruent. So that's that proof. And that completes the section on AAS is congruent to AAS.